Hello Algoranders! In this video we're going to learn how to use AlgoKit Utils. We're going to demonstrate and discover the whole capabilities of the AlgoKit Utils library in Python, and we're going to learn how to use the Jupyter Notebook that Algorand team has prepared for you. So let's get started. First thing you need to do is go into this website, which is example.algorand.co, and you will find here this example of the Python Utils notebook. Here you will see the Python Utils notebook option. You can go right there and you will find the whole Jupyter notebook right there. I'm going to clone the repository, so you need to click here in source, and I'm going to the whole repo. I'll clone the whole repo. I'm going to my terminal and I'll put git clone in the URL. Let's enter here, which is AlgoKit templates. And I'm going to select my local Python version. It depends on which version you're using. In this case, I'm going to use the 3.13, which is already selected. You just have to make sure you're using Python 3.13. Once you have the right Python version, you need to go to the folder of examples and you need to select the Python Utils notebook. Once you're there, you need to type poetry install no root, because we have some different projects into the same folder, so you need to put the no root flag so you can only install necessary dependencies of your project of the Jupyter notebook. We have to wait for a couple of seconds to be finished. And that's it. Next thing you need to do is only poetry run Jupyter Notebook. Remember, this is just like any other Jupyter Notebook. If you're already familiar with Jupyter Notebook, it's going to be easy for you. If you're not familiar with that, you just need to follow up the steps that I've just done right now. Hit enter. And this is going to open the whole Jupyter Notebook for us. Let's go here. And you will find the scripts for using AlgoKit Utils. Before this, we're going to make sure we have our localnet up and running. So we're going here, AlgoKit localnet status, and we can see there is one container that is not running. So we're going to type AlgoKit. Let's first find out our Docker so we can visualize our containers. And whenever you have some kind of issue with Docker, or you find any container that is not running, you can restart the whole installation of the AlgoKit localnet, or you can start from scratch. In this case, I'm going to put AlgoKit localnet reset. And as you can see here, it's going to restart the whole environment for AlgoKit localnet, for a local environment. Remember, this is something like a copy of a real network inside of your local machine, so you can start doing some tests and you can start playing with the whole network and you can discover how everything is working and interacting. Once you're done, you can go here, Lora.algokit.io, and you need to select the localnet so you can start watching all your interactions in your localnet. Okay, now we have everything ready. Let's start with our code. First thing in the AlgoKit Utils notebook is the imports for the whole project. So we're going to run this here. This is basically imports. And now we need to initialize an Algorand Client. An Algorand Client is the main interface or the main component for interacting with the whole network. In this case, as you can see here, we're using the Algorand Client part of the AlgoKit Utils library, and we are pointing to the default localnet. So we're going to interact with the localnet. Let's hit start run here. And now the next thing we need to do is create some localnet accounts. For creating any localnet accounts, basically we're starting to interact with the localnet. So you need to use the Algorand, which is basically the Algorand client we just instantiated here. That account from environment, remember the environment that we just selected is the full localnet, and you need to put a name for your account and the amount that you want to fund this account. In this case, we're going to start an account with 100 algos, and we're creating 2 accounts, Alice and Bob. So we're going to hit run, and let's wait for the response. And as you can see here, we have Alice account, which is basically RG0, and we have the Bob account, which is P0Y or POY, I think it is. So I have 2 different local net accounts already created. And if we go on this link, we'll find here the account, which already have balance of 100 algos. So everything is already created. So you can see here it's very easy to create some accounts in LocalNet thanks to the Algorand Client. Now let's get started with transactions. The most basic transaction that we have in Algorand is the payment transaction. Basically, it's transferring one or n algos from one account to another. For creating this, we're going to use as well our Algorand Client that send that payment. Send is basically for instantiate the transaction and send the transaction right after typing our line of code. And we're going to use the payment type of transaction. We need to add the payment params, which is another component object that we just imported here from the AlgoKit Utils library. As you can see here, payment params. And we need to add the whole parameters for a payment transaction. In this case, it's the sender, the receiver, and how many algos we want to send. Sender is going to be Alice, receiver is going to be Bob, that address, and the amount is going to be 2 algos. And we're adding a node. A node is going to be hi Bob. So let's run this piece of code. And as you can see there, pay transaction confirm, and we have the transaction ID. We can go into Lora, we can paste this transaction ID, and we will find the transaction right here. We have a transaction where the sender is RGO, which is Alice, and the receiver is POY, which is Bob, with an amount of 2 algos. And we have a node right here, hi Bob, which is a node that we just type in a piece of code. Next transaction we're going to do is sending an asset transaction, an ASA transaction. An Algorand standard asset is basically the main asset type in Algorand. It's the way for creating assets and managing assets in the Algorand network. So we're going to do something similar to the payment transaction. We're going to use the Algorand client, Algorand, that send, but in this case, we're going to change the payment transaction for an asset _create transaction. And we're using asset create params. We have some different parameters for creating an asset. Some of them are mandatories, some of them are optionals, but we're going to use the most common parameters for creating an asset. The sender, of course, we need to specify who is the sender of the creation, or who's going to be the creator. In this case, it's going to be Alice. The asset name is going to be my first ASA. The unit name is going to be MFA. The total, as you can see here, is this number, but this number will have 6 decimals, which means the last 6 zeros here are going to be the amount of times you can split an asset. If I use 1 decimal, it means one asset can be divided by 10 different pieces. If I use 2 decimals, every asset can be divided by 100 different pieces. So you can slice the asset in a lot of different pieces. So that depends on how you want to create your asset and how many slices of the asset you want to be able to create. In this case, we're going to have 1 million assets, but you can slice those assets into 1 million pieces, each one of the assets. Default frozen is going to be false, which means the asset can be freely transferred. If we have set this on true, that means nobody can move the asset or transfer the asset. The manager is going to be Alice, the creator. The reserve is going to be the Alice account. The person who can freeze the asset is going to be Alice, and the person who can claw back the asset is going to be Alice. We're adding a URL and we're adding a node as well. Now, let's send this. And we can see we have the asset ID 1004 and the transaction ID. If we copy the ID and we go to Lora Explorer, we'll find the asset we just created. As you can see here, we have only 1 million assets. but it has 6 different decimals per asset. Creator, manager, reserve, and everything. So we just successfully created the asset at the moment. Next thing, it's interacting with the API. Every node in the Algorand network that is running the Algorand software is going to be able to open the API. You can make any REST API call to the node and you can receive some different information or execute different transactions. You're already using right now the AlgoKit Utils library, but under the hood, the last thing on these functions or methods are basically API calls, because all the library is calling the nodes and is making some interaction, is making some actions into the node through a REST API call. But if we want to make some different API calls like getting information, we also can do it using AlgoKit and we don't have to worry about building the whole REST API call. Let's see an example. The asset info. We're getting the asset info using the Algorand Client, that asset, that get by ID, and we're adding the ID of the asset that we just store right here. So basically, whenever you want to check the information of any asset in the network, it doesn't matter if you have created the asset or any other person just created the asset. You can use this method and you will send an API call and you will get the information from the node. So let's hit run. And as you can see here, we're getting the whole JSON, which is basically the same information that we get in the Lora Explorer. But if you need any kind of programmatic key information in your application, you can use any API calls thanks to Algorand AlgoKit Utils, and you don't need to worry for building the whole API call. Now, remember, for using an Algorand asset, you need to opt in. Opt-in is like granting permission to the network to interact. So if at any time I create an asset and I want to send it to you, you won't be able to receive it because you haven't making an opt-in. If you want to receive my asset, you need to opt into the asset. So you need to grant permission to the network to interact with the asset, and the network is going to store an array with the relationship between you, your account, and the asset that you just make an opt-in. So making an opt-in is also very easy thanks to AlgoKit Utils. It's very intuitive. You just need to use the Algorand client that send that asset opt-in. And guess what? You also need to use a params here. But in this case, you only need to specify which account is doing the opt-in and what is the ID of the asset that you're opting in. Let's hit run, and you will see here there's an ASA opt-in transaction confirmed with this ID. Let's go to Lora, and we will find here an asset transfer. But the asset transfer has a subtype, which is opt-in. That's because an opt-in is basically a transfer of an asset. But I'm doing a transfer from my account to my own account. Basically, I'm sending a transaction to my own account, and the network is going to interpret this action like if you are granting permission, because if you're doing a transaction of an asset ID from your account to your own account, it means you want to interact with that asset. So the network is going to create this array for the relationship between your account and the asset, and you will be able to interact with the asset after the opt-in. As you can see here, this is a transfer of 0 asset from your account to your own account. In this case, from Bob's account to Bob account. Remember, Bob is the POY account. Next action is going to be sending the asset. So Bob has already opted into the asset, my first asset. So now Alice is going to send the asset to Bob. For this, we're going to use the Algorand client that send the asset transfer, and we're specifying here the sender is Alice, the receiver is Bob, the ID is the ID we just store in this variable, and we're sending 3 millions of the asset. But basically, this is only 3 assets. Remember, we have 6 decimals. So if we delete these 6 zeros, we're only sending 3 assets from Alice to Bob. Let's hit run, and let's go to Lora, and let's just verify. We have a transfer of 3 assets from RGO, which is Alice, to POY, which is Bob. So that's it. Now, if we want sometime verify that Bob has assets, we can send another API call. We can use Algorand.account.getInformation, and we specify the Bob address. This account, which is Bob, has an amount of 3 millions of the asset ID 1004, which is basically the MFA asset that Alice just created. If Bob has any other asset, you will see here a different extra information inside of the array. This is basically the relationships that Bob has with different assets. Now let's build an atomic transaction. Remember that an atomic transaction is basically when more than one transaction is created inside of the same group. If one fails, the other will fail. And you can group up to 16 different transactions into the same atomic transaction group. In this case, we're going to create one payment transaction and one asset transfer transaction. Two different transactions, because at this moment, Alice sent 3 assets to Bob. So Bob has already 3 assets. But now, Bob is going to send back one asset to Alice, and he's going to send one algo as gratitude, as saying, thanks Alice for giving me 3 different assets for testing. So we're going to send a new group because we need that these 2 transactions are completely correlated. So if one fails, the other will fail. We're going to use the Algorand Client that send a new group, and we're using this add and the type of transaction we want. Add payment, in this case, payment parents from Bob. The receiver is going to be Alice. The amount is going to be 1 algo and 1 node, which is thanks Alice. And we're adding another transaction, which is asset transfer, and we're specifying the sender is going to be Bob, receiver is going to be Alice, the asset ID is going to be the created asset, which is the variable. Remember that we just store the ID of the asset we just created, which is right here, remember. And the amount of 1 million, remember this is only one asset because we have 6 different decimals, and 1 node, sending back one of your token. And that send for sending this atomic transaction group. Now, the first transaction in the group is going to be this one here. So if we go to Lora, we'll find a transaction, but this transaction says it's part of a group. If you go to the group, you will find that the group transaction has a payment and one asset transfer from POY, which is Bob, to Alice. Bob sent a payment of 1 algo to Alice and a transfer of 1 asset to Alice. So as we can see here, everything is working correctly and it's very easy to use because you only need to have Algorand Client already instantiated and you can start sending different transactions. And the way for using the AlgoKit Utils library is very intuitive, it's very natural, very human. You can read this and anyone can understand what is your code doing. So this is basically really helpful for working with different developers, really helpful for learning how to use AlgoKit, and really easy to start your journey into the Algorand network. And if we want to get some transaction information from an indexer, remember the indexing is part of the software of the Algorand nodes, of the Algorand software, we can make even queries for getting some different information from the ledger. In this case, we're getting Algorand.client.indexer.search transactions, and we're making like a query where we need to get all of the transactions where the asset ID is the created asset, the number 1004, and the transaction type is a transaction asset transfer. So whenever we find some different transactions in the ledger that accomplish these 2 parameters from the query, we'll get those transactions. So let's hit run here. The result of the query of the transaction is basically these 3 transactions. This one here, this one here, this one here. And this is basically where are the transactions where the asset ID is 1004 and that has a type of transaction of asset transfer. One may be the asset opt-in, the other is when Alice sent 3 assets to Bob, and the other one is when Bob sent back 1 asset to Alice. Let's just verify this. You can see here the opt-in, that's correct. This one should be when Alice sent three assets to Bob. That's it. And the last one has to be when Bob sent one token back to Alice. And yeah, that's it. So as you can see here, you can also make some different queries to the ledger and get some different transactions. If you want, you also can make a query where if you want to know all of the payments that one account or one smart contract made to a specific account, you also can specify those parameters here, and you can create a query for getting your transaction. This is the way for interacting with Indexer. And as I already mentioned, everything is very easy to use here with AlgoKit, thanks to AlgoKit Utils in Python. You don't need to worry about building the whole API calls. I hope you like this video, and I hope you start playing around with AlgoKit Utils. Remember, we have built the whole Jupyter Notebook here so you can start playing around. And if you have any questions, you can find us on Discord. Thank you.